Hi, I'm Bob Reese. I'm with the National Marine Fisheries Service. We're standing here today at Big Canyon Creek. When the stream comes down to this part of the valley, it kind of widens out, and we have this place where all these rocks and sediment and everything spread out and would naturally form like a large floodplain in this valley. Historically, the stream probably meandered all through the valley from one side to the next. When the valley was developed, the stream got pushed over to the side, which often occurs, and housing developed throughout the drainage.
There's been a lot of floods on Big Canyon Creek, and they deposit gravel and cobble, and a lot of times one of the first reactions of people is to go move that gravel and cobble, to take a bulldozer and to push back and forth, and then the stream would have the capacity to carry the floods, right? Well, it would have the capacity to carry the water, but all of a sudden the water didn't get deep enough to move the rocks on down. And so each little storm deposited more and more gravel and cobble, and pretty soon our nice wide channel was full of rocks. The stream didn't have enough power to move all those rocks in the little flood, but in the big flood it could, and it would move them en masse. It would almost be an avalanche inside the channel as these rocks moved around.
Mark Reidinger. I'm the director of the road department for Nez Perce County. This is a bridge that historically has had issues with the channel filling in with debris, and consequently every year it would seem like we'd have to come in here, we'd have to clean the channel out, and of course it would just be a cycle that happened every year.
This job was started, the stream bed was at the bottom of the lower beam. In other words, it was plugged under the bridge. It was completely plugged. You couldn't even put your hand under the bridge.
It just didn't have enough freeboard, and that is the distance between the bottom of the bridge and the creek channel. So added about 12 more feet to the bridge and a little more width on it, and then of course we were able to get more height on it from the freeboard standpoint.
So to manage flooding in the future, I think everybody recognized that you have to have a floodplain somewhere in a system like this, and most of the floodplain was developed.
One of the main things we did here was to create some floodplain surface so that the water could get out and dissipate its energy out on this vegetated floodplain and not use all that energy wiping out the bed and banks as it moved all of the rocks.
So here is a place where we actually, for both fish and the people living here, we really kind of had a win-win situation where we got a wider floodplain. It conveys more water during floods, which reduces the energy and the flood risk, and we also get more of that meandering that's allowed to develop.
Those smaller floods are going to be slightly deeper and move those sediments on downstream, kind of smearing them out along the channel. And now when a big flow comes, the water gets about this deep and then flows out onto the floodplain, where it transfers a lot of the sediment out to the floodplain and burns up a lot of the energy that could have been kind of wreaking havoc on the bed and the banks of the stream.
It helps restore some of the habitat for fish, and it also reduced the flood risk in the future for the people that live here. It's been a benefit to really both fish and the people, and it's been a good project.